Hello. At the end of the previous lesson, I asked you what the results of the decomposition reactions told us about the reactivity of lead, copper, and mercury. Did you figure it out? Well, these results indicate that mercury is less reactive than lead because mercury decomposed completely while lead did not decompose at all. The copper 2 oxide also did not decompose as easily as the mercury. So we can say that copper is also more reactive than mercury. So, the final reactivity series that we have developed for metals during our investigation of metal reactions look like this. Potassium, sodium, lithium, calcium, magnesium, zinc, iron, lead, copper, mercury, and silver. Like any good puzzle, ours also reveal a picture. The man in our picture is Alfred Nobel. I'm sure that you've all heard of the Nobel Prizes. Mr. Nelson Mandela and Mr. F.W. de Klerk won the Nobel Peace Prize in 1993. Alfred Nobel was born in 1833 in Sweden and is the man who invented dynamite. He also made a donation of $9 million in his will, stipulating that the interest on this money should be used to award people whose work most benefited humanity. For the rest of this lesson, we will cross over to John's lab, where John and Seppo have a chemical mystery to solve. Why don't you get a pen and paper and join them?
We're here to solve a chemical mystery. Aren't you excited, Seppo?
Yes, I am.
Hey, that's great. Look what they've given us. They've given us the answers here, and we're going to put this box aside under here.
What are these for?
Oh, those are clue cards in case we get stuck. They've given us some unknown samples, A, B, and C. We're going to use the lab equipment here to try and identify what these things are. Looking at sample A, I'm going to use the white tile here to take it out of its container and have a look at it. Thank you. Right, let's pick it up more. It's stored in paraffin. Remember, it's a reactive metal. It's got a coating on it and it cuts really easily. Can you see that? It's a shiny surface. See how it's dulling down as the air reacts with it. I think we need to record our results here. Won't you go to the board and write them down? In the meantime, I'm going to get the Bunsen burner going. How are you doing there with those results? Remember, it's pale grey, it's stored in paraffin, it reacts with oxygen, and it's really quite soft. Have you got those?
Got it.
Right, those observations look just like characteristics of group 1 metals, the alkali metals. So, I think we need to confirm which alkali metal it is by doing a test of burning the sample in oxygen. There we go. I'm now going to put it into the Bunsen flame. It's melting down nicely. Now into the oxygen.
Wow, that's beautiful. Look at that purple color.
Now that was a dead giveaway, wasn't it? Sodium burns with a yellow flame, lithium with a pink-red flame, potassium with a lilac flame, and copper with a green-blue flame. The lilac flame means that it must be potassium. Let's go and write down what we've seen on the board. Can you remember what the symbol is for potassium, Seppo?
Of course, it's a group 1 metal. It's K.
That's right, you've got it absolutely right. Now remember, all metals react with oxygen to form a metal oxide. And in this case, we're going to write down the symbol K plus O2 to give you K2O. And now we're going to balance it. We're going to put a 2 there and a 4 there. Now, Seppo, The reason that group 1 metals are called alkali metals is because they are both basic and soluble. So we need to test the oxide that we've just formed by dissolving it in water and putting some litmus paper in it.
Great, let's do it.
Good. I'm going to use this test tube over here. I'm going to take the oxide that was formed on the deflagrating spoon, scrape it off into the test tube. I'll try and get some more out. We're then going to take some water, pour in the water. The reason that this solution has gone a pinkish color is because we might have some iron oxide from the spoon mixed in with the potassium oxide. Add some litmus paper. Let's see what happens. Can you see the litmus paper has gone blue? Over there at the top. It's quite clear. So the oxide was definitely soluble and basic. That means that it definitely was a group 1 metal. Remember, all metals react with oxygen to form metal oxides, but they don't all look the same. I've got some samples here that will help us in our investigation in trying to solve our mystery. Let's have a look at them. Here we have calcium oxide, zinc oxide. These oxides are all white, but look at these ones. This is iron oxide, lead oxide, copper 2 oxide, and mercury 2 oxide. What we've established so far in our investigation is that metal oxides are all basic and that the reactive metals form white powders. With this in mind, let's go and look at sample B. As you can see over here, it is a white powder, so perhaps we're on the right track. But we'll need to test it by dissolving it in water. So let's do that now. And we're going to put some powder into this test tube here and add water and shake it up.
Well, not all of it seems to be dissolving.
That's right. Remember that not all metal oxides do dissolve. But the important thing is that they are all basic. So we need to test it with litmus paper. Won't you put that in for us?
The fact that it's turning blue must mean it's a basic solution.
Absolutely correct. All metal oxides are basic. All metal oxides of group 1 metals are very soluble. Well, we know it's not an alkali metal, but that doesn't really help us much. Let's check out the periodic table. It can't be one of these group 1 metal oxides, but it could be one of these. We know these ones are white, and there are some here that are white as well. However, we know that it can't be an unreactive metal oxide because it's white. It doesn't help us to heat it because reactive metal oxides are thermally stable. So I think we're stuck. Won't you get us the clue card?
Okay. The metal that this white powder comes from reacts with cold water.
That's a really important clue. It helps us recognize that it can't be any one of the transition metals because none of the transition metals react with cold water. However, it could be one of the group 2 metals. Can you remember what we've learnt about group 2 metals? When we placed calcium in cold water, it reacted and produced bubbles of hydrogen gas. When we did the same reaction with magnesium, a very slow reaction happened and hardly any bubbles of hydrogen gas were visible. We've got it! Sample B must be calcium oxide. In the process of this part of the investigation, we've also learnt 2 important general principles. Let's write them down as equations. A metal oxide plus water will give us a metal hydroxide. That's the test that we did. We can write the equation for calcium here. Calcium oxide plus water gives us calcium hydroxide. And then we've also learnt that a metal that is reactive plus water will give us a metal hydroxide plus hydrogen gas. Seppo, I think it's time to look at sample C.
Okay, let's do it.
As you can see, it's a blue powder. It can't be one of the oxides that we've studied. None of them were blue. But what element do we know isn't a blue crystalline substance?
Copper.
That's right. Let's make up a solution. Put it into this test tube. Add some water. And give it a stir. Once we've got a solution, what we can do is we can do a displacement reaction. Now we know most things are more reactive than copper, so pass me that zinc powder over there.
Here you go.
Thank you. Can you see that it's changing color here at the bottom?
It's turning like a brownish red.
That's a definite indication that we've got copper. So we definitely have a displacement reaction. We're almost 99% sure that our substance contained copper. But to check, won't you pick up the clue card?
This blue stone will dissolve in water to form a solution with sulfur ions present.
That's right, we have it. You see, another name for copper sulfate is bluestone. So we know what sample C is. It must be copper sulfate. In the reaction that we saw, copper sulfate, CuSO4, reacted with zinc metal to form zinc sulfate plus copper, the orange deposit that we saw. Can you see that the more reactive metal has kicked out the less reactive metal? This is a clear displacement reaction, leaving us with copper as the orange deposit. Thank you. I hope we've got it right. Right. Sample A. Won't you open it up and check? Sample A, we think it was?
Potassium.
We got it right. Sample B.
Calcium oxide.
Correct again.
Sample C, copper 2 sulfate.
What do you know? We solved the mystery. Well done. As you can see, we've also arranged them in the correct order of reactivity. Remember, potassium is more reactive than calcium, and calcium is more reactive than copper. So, we've solved the mystery.
I'm sure that you enjoyed solving that mystery. This lesson concludes our investigation into the reactions of metals. In our next series, we look at the reactions of nonmetals. See you then.